In this video, I'm going to cover how to calculate a one-way ANOVA in Excel. One using the data analysis pack and the other one doing it manually. The data analysis Toolpack is something that you can enable on Excel. So you just Google data analysis Toolpack on the web and get those instructions on how to enable it if you don't have it. But it's here in the data tab. So with ANOVA, this is the description that we get from Wikipedia. It's a technique that compares two or more samples. Usually, if it's just two samples, they consider using the student t-test. But you can also do the ANOVA for two or more. But if it's usually three or more, this is where they kind of expound here, three or more, then ANOVA is probably the way to go. And basically what ANOVA does is it compares the means between groups and it helps you determine if they're significantly different from each other. Oh, and I spelled each other with each other. Let's get rid of that. So when we're testing and to see if they're different from each other, we're basically testing the null hypothesis and seeing if the means of each of the groups equal each other. If it doesn't equal each other, that means we would reject the null hypothesis. We wouldn't accept the null hypothesis. Now, the ANOVA test, it doesn't tell us which specific groups are different, only that at least two groups are different. So there's some assumptions in ANOVA, and they're down here. And the three assumptions are that our data is normally distributed, the variances are equal, and the responses are independent of each other. So let's see how we can get a ANOVA result from some data. Let's say we have four vendors. We're a company. We have four vendors that provide services to us. And we send out a company survey to see how these four vendors are doing. And we get back four responses. And we have a small company. How do we know that these scores are random? Or do we have other factors like the age of our survey takers or some unknown relationship to the vendor that have influenced these results? Well, an ANOVA test would be able to tell us that. So we set up our hypothesis, and our H sub 0 or H naught is telling us that there is no significant difference between the vendor mean scores. That's the assumption. Now the alternative hypothesis would say that there is a significant difference between the vendor mean scores. So how do we get this in the data analysis? So I've mentioned before, we have a data analysis feature here. All I need to do is bring it up. And if I go to the very top here, we have the ANOVA single factor. That's the one that we're going to use. Click OK. Our input range is going to be from B2 to E6. And the data is grouped by columns. We have vendor 1, vendor 2, vendor 3, vendor 4. And since I included the headers, I'll say the labels are in the first row. Our alpha is 0.05. We're using a 0.05 significance level. Let's see, I'm going to put this output range, let's just put it in the worksheet here. I'll put it in cell I5. Click OK. And we have our ANOVA table. Double click the columns to auto fit. So what do we make of this data? What we really want to look at is our F statistic. Let's color that. And compared to the F critical statistic. Now, if our F statistic is greater than our F critical statistic, then we are going to reject the null hypothesis. But here you see our F statistic is less than our F critical statistic, so we do not reject the null hypothesis. We're saying the average scores, which are given here for vendor 1 is 6, vendor 2 is 4, vendor 3 is 5, and vendor 4 is 5. We're saying that those mean scores, there is no statistical significance difference between them. So we accept them. They're okay. We're not going to say that there's going to be some unknown factors that influence these results. Now, that was the easy part because Excel has done all that work for you using the data analysis Toolpack. Now, if you wanted to get a little bit more challenged by how we got to these values, we can go the manual route here, and I'll kind of go into that right now. So here we are with our data again. We've got our same data here, and we've got our same hypothesis set up.
We want to get the average values here, so I will type in sum or average, double click that, average those values there, press return. So I have an average of 6 for vendor 1. I'm going to drag the fill handle across, so it's going to copy the formula across and give me the averages for each one. I need to get a grand mean for everything, so what is the average for all the scores here? So I'll type in average, double click that, and get my average of all the scores there, press enter. So to get my sum of squares total, I need to get the variance between each of the scores minus the grand mean and square it. And then once I get it for everything, I have to sum it up, and that's how I'm going to get that. So let me take this particular function, Control C to copy, escape, delete that. And I'm going to select everything here and just put that formula into the whole cell and use a keyboard shortcut, Control Enter, that will execute it for all the cells and also keep the references involved when it's performing the calculation. And we'll see what happens. I'll show you what that means when we do that. But before I press Control Enter, I need to make sure that I have this cell, A3, as an absolute cell reference. So I'll press the F4 key so I get my dollar signs in front of the letter and the number. Because what happens when I press Control Enter, it's going to execute this particular function, and C3 becomes C4 in this cell, and C3 it becomes C5 in this cell, because it's going to reference the different cells as it copies it over. So press Control Enter, and we have our calculations. As you see what I mentioned here, this becomes C4. It was C3 earlier. This becomes C4, C5, and also the other corresponding cells or column cells here. We have D3, D4, D5, and that's the nice thing about selecting a cell range and performing this calculation. You can have it done all at once by just using the Control Enter key. So now with the sum of the squares total, I just need to sum it up. Press Tab here, sum all this up, press Enter, and I get my value of 52. Our next calculation that we have to do is the sum of squares within. So this is the variance of each of the vendors within their own averages. So in this case, it's going to be equal to open parentheses, this vendor minus their average, and then square it. Press Enter. So you get that value. Here I need to make sure that when I copy it over, that column stays the same, or that row stays the same, but the columns can change. So all I need to do is have the dollar sign in front of the 7. Alright, press Enter. Whoop, I didn't need to do that yet, but I'm going to copy this, Control C to copy, press Escape, and let's delete this, and I'm going to select everything now. Control V to paste that back in, Control Enter, and it's going to copy that formula all the way through. You can see cell C7 stays the same here for that column. If I go to the next column over here, it's going to go to D7, which is this value, right? So you can see that the red color here kind of aligns to the red box here, and D4 aligns to that. Press Escape. So I've got my calculations all set up here. So these are the squares within, and I need to sum that up now. Press Tab, and then sum all this up. Press Enter, and I got the value of 44. Now the third variance I got to find is the squares between. So this is going to be my average for each group minus the grand mean and multiply it by the number of responses within each group. So this is going to be equal to the average, put this in parentheses, minus the grand mean, and that's going to be an absolute cell reference, that's not going to change. Square that, and then multiply it by 4, right? Because each
each group has 4 responses. Press enter. We've got our value there. Just drag the fill handle to bring it over. This one's easier, so I don't need to select it and control return. And I have my values here. And this is going to be the sum of all this. Press enter, and we've got 8. So we've got our sum of squares total, our sum of squares within, and our sum of squares between. What do we do with these values? Let me bring this box over here. So what we need to do is we need to get our F statistics based on our SSB and our SSW. That's right, so we have our SSB and our SSW. So you might think, why would we need to calculate our SST? Well, when you think about it, it helps us provide a check, because we see that the addition, if we sum up SSB and SSW, it will always equal to SST. So we have that calculation there. So think of it as a check. Now you might also see SSB as SSC, sum of squares columns, and SSW as SSE, sum of squared errors. I think in Excel that's what they do. Let's see, sum of squares. No, it doesn't even tell you, but it just tells you it's between and within. But you may see some documentation refer to SSC, which is the same as SSB, or SSE, which is the same as SSW. So how do we figure out the F statistic? Well, we're going to have to do this calculation. So it's going to be equal to SSB, or sum of squares between, let me put that in parentheses, this value divided by our M minus 1. So M is the number of groups. We have 4 groups, right? Vendor 1, 2, 3, and 4 minus 1. So that's basically the degrees of freedom. So we're going to have M minus 1, 4 minus 1 is 3, right? And then we have to divide that. Let's put this whole thing in parentheses now. We're going to have to divide this by SSW. Let me open up my parentheses here. SSW divided by N sub T, which is the number of observations. So there's total 16 observations, right? There's 4 here, 4 here, 4 here, 4 here. 4 times 4, 4 vendors is 16. And the degrees of freedom here, NT minus M, is going to be 16 minus M, which is our 4 groups. Close parentheses, and that's purple color. We want to get a black color closing parentheses. I think that's it. Press enter. And our F stat is 0.727, which is the same as this F stat. 727, right? So if we do our manual calculations here, how do we figure out the critical value? Well, that's something that we need to get from a table. So if I brought in a table, let's just search the web for a table for an F statistics distribution table. We see we have our F distribution table for 0.05, and I brought this one up here, and the degrees of freedom for the numerator here is 3. So degrees of freedom for the numerator is this M minus 1, that's 4 minus 1, so that's going to be 3. And our degrees of freedom for the denominator is N sub T minus M, that's 16 minus 4. So 16 minus 4 is 12, right? So if we go back to our table here, we have numerator 3, we have our denominator 12. The intersection of that, 3 and 12, is 3.49. So we have our 3.49, which is our F critical value. And we can see here the F critical value given from Excel, the data analysis toolpack was is 3.49. And that's similar to what we found on our table. So our F stat is less than our critical value. So we accept the null hypothesis. There is no significant difference between the vendor mean scores. So what we're safe to say here is that these scores are random, and we can accept that. Now, whether you use the data analysis toolpack or you want to be challenged to have those manual calculations, that is how you can perform a one-way ANOVA in Excel. So I hope that helps. Thanks for watching.